Hey guys, my name is Moses and this is Programming Learning channel. This channel is dedicated to programming and here I will do series on different types of programming methods, and today in this video we will see about examples of logic gates using normally open and normally closed contact. Okay, let's begin. In my previous video we saw about latching operation using normally closed contact and examples of logic gates using normally closed contact. And now let's start this video with examples of logic gates using normally open and normally closed contact. And the first logic gate is XOR gate, and the example used here is the part of all PLC program, that is process selection. Here the condition is to make the machine run either in auto mode or manual mode. This is the program, and here X0, X1 and X2 are the inputs emergency, auto mode and manual mode, and Y0 and Y1 are the outputs automatic and manual process. This is the truth table. Here X0 is the emergency, and as mentioned in my previous video, this is one of the major safety feature in a machine, and here I have used normally closed contact for emergency, but the type of contact used for emergency in the program depends on the type of emergency switch used in the machine. If a normally open type of switch is used in the machine, then a normally closed contact will be used in the program, and if a normally closed type of switch is used in the machine, then a normally open contact will be used in the program. And since here I am just simulating the program, I am using normally closed contact. Okay, here we have two motors. First let's switch on auto mode, that is X1. Output Y0, which is automatic process, is on. Now let's try to switch on manual mode. Both the outputs are off. So to switch on manual mode, first let's switch off auto mode. Manual process is on. By this we can conclude that at a time only one process can be selected, and here XOR gate is used to do it. To understand the working of process selection in the machine, let's watch this animation. Along with this, we will also examine some of the modes used in automated machines. This is a cut to length machine. This machine cuts the metal rods according to the desired length, and we have already seen the parts of the machine in this video. In this video, I have removed the safety sensor. First, let's run the machine in auto mode. For that, click on this button, and now if I click on this manual mode, see, none of the modes are selected. Okay, let's continue with the auto mode. As soon as this rod sensor detects the rod, the pusher stops and the cutting process starts. In this way, the pusher pushes the rod and the cutter cuts the rod automatically. And after completing the process, both the cutter and the pusher go back to their home position and the process repeats. Now let's see the next mode, which is emergency mode. Let's start the process. Since this piece of rod is blocking the sensor, the cutter is not stopping, so in such situation emergency is used to stop the process, but because of the emergency button, all the moving parts are stuck and are not in their home position. If we start the machine now, it may damage the parts of the machine. So to send back all the parts back to the home position, manual mode is used. In manual mode we have two methods, homing and moving parts manually. First, let's see homing operation. Here we have removed the workpiece, but the cutter and the pusher are stuck. Let's release the emergency button. Select the manual mode. In all these options, this is homing button. When this button is pressed, all the parts return to their home position. So in this way, the homing button is used. Now let's see the second method. In this situation, we cannot use homing method because the pusher may collide with the cutter. So here we have to move the parts individually. First, release the emergency button. Now select manual mode. Here these are the options to move parts individually. First, let's move the cutter up. Now let's move the pusher. So in this way all the parts are moved manually, and these are the modes commonly used in automated machines. And before we continue, if you have understood the video so far, then please like the video And if you have liked the video, then share it with your friends. And if you have any doubts, then write them in the comments. And if you want to see more videos from this channel, then please subscribe to the channel and press the bell icon. Okay, now let's see the next logic gate, that is XNOR gate. And the example used here is speed comparison between two motors. The condition here is to compare the speed between two motors in real time, and if the speeds are equal, then the process continues, and if not, then an error signal is generated. This is the program, and here X0, X3 and X4 are the inputs: emergency, motor off sensor and speed comparison output respectively, and Y2, Y3 and Y4 are the outputs: checking, continue and error. This is the truth table. Let's know what is the logic behind the program. According to the condition, we need to check whether the speed of two motors is same or not. The input X3 will tell us whether if the motor is on or off. And input X4 is to check if the speed values of both the motors is same or not. The actual comparison of values in WPLSoft is done using this method. This complicates the program, so I have replaced this with a normally open contact. Now we know why these two parameters are taken as input. Now let's run the program. Here the motors are off, so the speed values are same, which is 0. So the checking continues. Now motor switches on. If the speeds are different, then there will be an error signal, and if the speeds are same, then the process checking continues. So in this way, XNOR gate is used in this program to check if the motors are off and the speed are 0, or the motors are on and the speeds are equal. Let's now watch the animation to understand how this program works. Here these are the two motors M1 and M2. This is the block that compares the speed and determines whether the process must continue or should be stopped with an error signal. Now let's start the motors. The speed values are sent for the comparison. Both the speeds are equal, so the process continues. And if the motor speeds are different, then the process will stop with an error signal. So in this way, XNOR gate is used in this example. Okay, now we have come to the end of this video. So far in this video we saw about examples of logic gates using normally open and normally closed contact, and in the next video we will see about rising edge triggering switch and falling edge triggering switch. Okay, this is it for today's video. Until next video, stay cool, calm and confident and stay subscribed. Thank you.